Hello there, and welcome to Whispers of Science, where the cosmos gets contemplative and physics puts on its softest slippers. Tonight, we're embarking on a gentle journey toward the most profound ending imaginable, the heat death of the universe. That final whisper when all the stars have burned out, all the energy has spread thin, and time itself might finally rest. Now I know what you're thinking. Heat death doesn't sound particularly cozy, does it? But before we drift into existential worry, let me tell you something beautiful about this cosmic finale. It's not violent or sudden, it's the universe slowly settling into the deepest, most peaceful sleep imaginable, like an old friend finally laying down to rest after the longest, most extraordinary day. Before we begin this quiet voyage into forever, I'd love to know where in the world you're listening from and what time it is in your corner of the night. There's something fitting about exploring the end of time while we're all scattered across different moments, each of us arriving at this very second from our own unique slice of now. If you find this journey soothing, thought provoking, or simply a gentle way to drift off after a long day, I'd be ever so grateful if you gave the video a like and perhaps subscribed it. Helps this little corner of cosmic calm reach others who might need a peaceful pause in their evening. Now, I do hope this isn't so fascinating that it keeps you awake, but if it does, well, at least you'll have learned something about the ultimate destiny of everything before you slip into dreams. So settle in, slow your breathing, and let's begin. Because somewhere between the first spark of creation and the last flicker of light lies a story both melancholy and magnificent. Imagine, if you will, the universe as a grand old house that's been hosting the most wonderful party for nearly 14 billion years. The music has been playing, the lights have been twinkling, and countless guests have come and gone, leaving behind memories, laughter, and the gentle warmth of life lived fully. But now, as the evening grows late, the music is beginning to fade. The lights are dimming one by one, and the guests are slowly making their way home. This isn't a story of tragedy, though it's a story of completion, the natural conclusion to the most beautiful celebration ever thrown, and our universe, like that grand old house, is gradually winding down toward its own gentle conclusion. The heat death of the universe is perhaps the most elegant ending cosmologists have ever conceived. It's not a bang or a crunch or a tear, it's a whisper, the softest possible goodbye from a cosmos that has given us everything: stars and planets and chemistry and biology and consciousness and love, all slowly settling into the most profound tranquility imaginable. But what exactly is heat death, and why do scientists believe this is how our cosmic story ends? Well, it all begins with a rather simple observation that energy, like water, always flows from hot to cold, from concentrated to spread out, from ordered to scattered. It's the second law of thermodynamics, dressed up in cosmic clothes, and it suggests that the universe is like a cup of hot tea, slowly cooling in an infinite room. Picture this. You brew a perfect cup of tea, steaming and fragrant, and set it on the table. At first, it's wonderfully hot, concentrated energy in liquid form, but left alone, it begins to cool. The heat spreads outward, warming the air around it, until eventually the tea reaches room temperature, and then it just sits there, no longer giving off heat, no longer changing, just perfectly evenly cool. Now imagine the universe as that cup of tea, but instead of cooling for a few hours, it's been cooling for nearly 14 billion years, and it will continue cooling for trillions upon trillions of years more until everything everywhere reaches the same gentle temperature, and all the energy that once created stars and planets and you and me has spread out so evenly, so peacefully, that nothing interesting can happen anymore. This is the heat death. Not because everything becomes hot, but because heat energy itself becomes so evenly distributed that there's no difference in temperature anywhere, no gradients, no flows, no way for energy to do the work of creating complexity or sustaining life. It's the universe achieving perfect thermal equilibrium, a state of maximum entropy where every corner of space holds exactly the same amount of energy at exactly the same temperature. Now you might wonder how we got from the Big Bang, that tremendous explosion of creation, to this gentle fade to black. Well, it's been a gradual process happening so slowly that entire civilizations could rise and fall without noticing the change. But the signs are there, written in the very fabric of reality itself. When our universe began, it was incredibly hot and dense. All the energy that would ever exist was compressed into a space smaller than a grain of sand. Then came the expansion, cooling and spreading that energy outward like ripples on an infinite pond. As the universe grew larger, it grew cooler, and the energy that once created the first particles, then the first atoms, then the first stars became increasingly diluted. Think of it like this. Imagine you have a small room with a fireplace blazing brightly. The room is wonderfully warm, but then the walls begin expanding outward slowly at first, then faster and faster as the room grows larger. The same amount of heat from the fireplace must warm an increasingly vast space until eventually the room is so enormous that the fireplace can barely warm even the area immediately around it. This is what's happening to our universe on the grandest scale imaginable. The energy from the Big Bang is still here. It hasn't disappeared. Energy cannot be created or destroyed, only transformed, but it's being spread thinner and thinner across an ever expanding cosmos, like a pat of butter scraped across an increasingly large slice of bread. And here's where it gets both beautiful and melancholy as this cosmic cooling continues. The stars, those magnificent fusion reactors that have been lighting up the darkness for billions of years, are slowly running out of fuel. They're burning through their nuclear reserves, converting hydrogen to helium, helium to carbon, and so on, up the periodic table until they can burn no more. The largest stars will go out first in spectacular supernova explosions, scattering their enriched contents across space to seed new generations of stars and planets. But even these stellar nurseries are becoming rarer. The universe isn't making new hydrogen anymore, and without fresh fuel, the star formation rate is declining. Each generation of stars is smaller and redder and longer lived, but ultimately finite. Our own sun, that gentle yellow star that makes life possible on Earth, has about 5 billion years of fuel remaining. Then it will swell into a red giant, engulf the inner planets, and eventually shed its outer layers, leaving behind a white dwarf, a stellar ember about the size of Earth, but containing most of the sun's original mass. White dwarf stars are remarkably long-lived. They can shine for trillions of years, slowly cooling and fading, but even they will eventually succumb to the cosmic chill. They'll cool from white hot, all becoming cold dark objects, to red to infrared to nothing, at drifting through an increasingly empty universe. But even after the last star fades, the universe won't be completely dark. There will still be the occasional flash as wandering planets fall into black holes, or as the black holes themselves slowly evaporate through Hawking radiation. Yes, even those cosmic monsters, the most extreme objects we know of, will eventually disappear. Given enough time, Hawking radiation is perhaps one of the most poetic discoveries in modern physics. It tells us that black holes aren't perfectly black. They emit a gentle glow so faint that it would take longer than the current age of the universe for even the smallest black hole to lose a significant fraction of its mass. But time is the one thing the universe has in abundance, and patience is its greatest virtue. As the eons pass and the black holes slowly shrink and disappear, the universe will be left with only the most stable particles, electrons, protons, perhaps some photons of light, stretched so thin by the expansion of space that they carry almost no energy at all. It will be a cosmos of perfect darkness, perfect silence, perfect stillness. And yet there's something almost comforting about this ending, isn't there? It's not violent or chaotic, it's peaceful, gentle, inevitable, like the universe itself is slowly falling asleep after the longest, most productive day imaginable. Every star that ever shone, every planet that ever formed, every thought that was ever thought will have contributed to this cosmic story. The heat death represents the ultimate triumph of entropy, the tendency for order to become disorder, for complexity to simplify for differences. To even out, it's the universe's way of finding perfect balance, perfect rest, perfect peace. And in that sense, it's not really an ending at all, but a completion. Imagine a vast symphony that has been playing for billions of years, with themes and variations, movements and crescendos, all building toward a final note that lasts not for seconds or minutes, but for eternity, a note so pure and perfect that it contains within it the memory of every melody that came before. This is the heat death of the universe, not a crash or a scream, but the softest possible conclusion to the grandest story ever told. And while it may be trillions of years in the future, it's already begun. The universe is already cooling, already spreading its energy thinner, already taking its first gentle steps toward that final peaceful sleep. So, as we drifted deeper into this cosmic lullaby, let's explore how scientists first discovered this destiny, how they pieced together the clues written in starlight and cosmic background radiation, how they learned to read the universe's own diary and discovered that every page points toward the same quiet conclusion. The story of how we discovered the universe's gentle fate begins in the most unlikely of places, with a baked potato and a stubborn piece of metal. In 1800, William Herschel, the astronomer who discovered Uranus, was playing with sunlight and a prism, much like you might have done as a child watching rainbows dance across your bedroom wall. But Herschel was curious about something nobody had thought to investigate. If light could be split into different colors, might those colors carry different amounts of heat? So he set up his prism, spread the rainbow across his table, and placed thermometers at different points along the spectrum. Blue light, green light, yellow, red, each measurement carefully recorded. But then, almost by accident, he placed a thermometer just beyond the red light, in what appeared to be empty space. To his astonishment, this invisible region was the hottest of all. He had discovered infrared radiation, light we cannot see but can most certainly feel. This discovery would echo through the centuries because it revealed something profound. The universe is constantly bathing us in invisible messages, stories written in wavelengths our eyes cannot perceive. And it was in these hidden frequencies that scientists would eventually find the universe's own confession about its ultimate destiny. Fast forward to 1929 to an astronomer named Edwin Hubble peering through the massive telescope at Mount Wilson Observatory in California. Hubble was studying distant galaxies, those island universes scattered across the cosmic deep, when he noticed something extraordinary. The light from these galaxies was shifted toward the red end of the spectrum, stretched like the sound of an ambulance siren fading into the distance. This redshift, as it came to be known, told an astonishing story. The galaxies weren't just sitting peacefully in space, they were rushing away from us, and the farther away they were, the faster they seemed to be fleeing. It was as if the universe itself was expanding, carrying every galaxy along like raisins in a rising loaf of bread. But here's where it gets beautifully melancholy. If the universe is expanding and cooling now, then logically it must have been smaller and hotter in the past. Wind the clock backward far enough, and you arrive at a moment when everything we can see was compressed into a point smaller than the period at the end of this sentence. The Big Bang wasn't just the beginning of space and time, it was the moment when the cosmic cooling began. Picture a balloon being inflated in slow motion. As it grows larger, any pattern drawn on its surface spreads out, becomes less dense, less concentrated. Our universe is like that balloon, but instead of air filling it, it's space itself that's expanding, carrying galaxies along for the ride and making the distance between them ever greater. In the 1960s, two radio astronomers named Arno Penzias and Robert Wilson stumbled upon perhaps the most important discovery in cosmology while trying to eliminate an annoying hiss from their antenna. No matter where they pointed their radio telescope, no matter how thoroughly they cleaned it, even going so far as to remove nesting pigeons and their droppings, the mysterious static persisted. What they had found, quite by accident, was the cosmic microwave background radiation, the afterglow of the Big Bang itself. This faint whisper of ancient light, now stretched and cooled by billions of years of cosmic expansion, fills every corner of space. It's the universe's baby picture, a snapshot from when it was only 380,000 years old and still glowing like the embers of a cosmic campfire. This background radiation told scientists something remarkable about the universe's temperature. Today, this ancient light has cooled to just 2.7 degrees above absolute zero, that's minus 270 degrees Celsius, colder than anything naturally occurring on Earth. But in the beginning, when this light was first released, the entire universe glowed with the heat of a star's surface. The mathematics of this cooling process is surprisingly elegant. As the universe doubles in size, its temperature drops by half. Double again, and it halves once more. It's been cooling steadily for nearly 14 billion years, and it will continue cooling for trillions more, approaching but never quite reaching that perfect zero where all molecular motion ceases. Scientists call this absolute zero, and while the universe will never quite get there, it will come tantalizingly close. In this far future, the temperature difference between the coldest and warmest places in the cosmos will be so small that you could measure it in billionths of a degree. No energy gradients means no weather, no chemistry, no life, no reason for anything interesting to happen at all. But the cosmic cooling is just one part of the story. There's also the matter of cosmic acceleration, a discovery so unexpected that it earned its discoverers the Nobel Prize and left physicists scratching their heads in bewilderment. In 1998, two teams of astronomers studying distant supernovae, those spectacular stellar explosions that briefly outshine entire galaxies, made a shocking discovery. They expected to find that the universe's expansion was slowing down, like a ball thrown upward, gradually losing speed as gravity pulls it back. Instead, they found the opposite. The expansion is speeding up. Something is pushing the universe apart with ever increasing vigor, stretching space itself and accelerating our journey toward that final thermal equilibrium. This mysterious force has been dubbed dark energy, though it's neither dark nor energy in any conventional sense. It's more like a property of space itself, causing empty vacuum to push outward with a gentle but relentless pressure. About 70% of the universe consists of this dark energy, making it the dominant component as of reality. Yet we understand it about as well as a medieval scholar understood electricity. What dark energy means for the heat, death is both profound and slightly unsettling. Not only is the universe cooling as it expands, but that expansion is accelerating, meaning the cooling will happen faster and more thoroughly than anyone previously imagined. Galaxies that we can see today will eventually be carried so far away by this accelerating expansion that their light will no longer be able to reach us. Imagine standing on a beach, watching ships sail toward the horizon. At first, you can see their sails clearly, then just their masts, then nothing at all as they disappear beyond the curve of the earth. Dark energy is doing something similar to our cosmic neighborhood, carrying distant galaxies beyond our cosmic horizon until they vanish from view forever. In perhaps 1 trillion years, an astronomer in the far future will look up at the night sky and see only the stars of our own galaxy, plus whatever other galaxies our gravity has managed to hold on to. The rest of the universe will have been stretched so far away that it might as well not exist. They'll live in an island of light, surrounded by an ocean of darkness, with no way of knowing about the billions of other galaxies that once sparkled in their ancestors' sky. This cosmic isolation is part of the heat death story. As galaxies drift apart, they can no longer share energy or matter. Each becomes its own closed system, slowly burning through its stellar fuel with no possibility of replenishment. It's like watching a city gradually lose contact with the outside world, using up its supplies until eventually lights the go out one yet by one. And even in this seemingly bleak future, there's a strange beauty to contemplate. The universe isn't dying in any violent sense. It's simply completing its natural cycle. Every star that burns, every planet that forms, every life that emerges is part of this grand cosmic story. A story that began with tremendous energy and complexity and will end with perfect simplicity and peace. The physicists who first calculated these cosmic timescales must have felt a peculiar mix of awe and melancholy. Here they were, using the most sophisticated mathematics humanity had ever devised to predict the ultimate fate of everything that exists. Their equations, elegant and precise, all pointed toward the same gentle conclusion. The universe will end not with a bang, but with the softest possible whisper. And yet, within this cosmic countdown, There's something almost miraculous happening right now. While the universe slowly unwinds its grand clock, complexity continues to flourish in the most unexpected ways. Life finds a foothold on countless worlds. Consciousness emerges from the dance of atoms, and somewhere in the vast darkness, beings like us pause to contemplate their own existence. It's rather like watching a candle burn in a gentle breeze. The flame flickers and wavers, sometimes growing brighter, sometimes dimmer, but always reaching upward towards something greater than itself. The candle knows it will eventually burn out, yet it continues to give light and warmth for as long as it can. Our universe, in its own magnificent way, is doing precisely the same thing. The timeline of cosmic events stretches before us like chapters in the longest book ever written. We're currently living in what cosmologists call the stelliferous era, the age of stars, which began roughly 1 billion years after the Big Bang and will continue for perhaps 100 trillion years. In cosmic terms, we're still in the early pages of the stellar chapter, with the universe appearing young and vibrant and full of promise. During this era, stars continue to form in stellar nurseries scattered throughout spiral galaxies. These cosmic cradles, often called nebulae, are vast clouds of gas and dust where gravity slowly pulls matter together until it becomes dense enough to ignite nuclear fusion. Each new star is like a lighthouse switching on in the cosmic dark, announcing its presence with the steady glow of hydrogen burning into helium. But even now, subtle changes are taking place. The universe is no longer as rich in hydrogen as it once was. Each generation of stars locks away some of this primordial fuel, converting it into heavier elements that will never again participate in stellar birth. It's a slow process, barely noticeable on human timescales, but over billions of years, it means that star formation is gradually declining. Think of it like a grand fireworks display that began with tremendous bursts of light and color, and now, hours later, is down to the occasional sparkler and Roman candle. Still beautiful, still capable of taking your breath away, but clearly winding down toward its inevitable conclusion. The universe's fireworks show has been going on for nearly 14 billion years, and while there are still plenty of sparklers left to light, the grand finale is already written in the mathematics of thermodynamics. Our own Milky Way galaxy offers a perfect example of this cosmic aging process. Once, it was a spiral of brilliant blue stars, hot and massive and burning through their fuel with reckless abandon. These stellar giants lived fast and died young, exploding as supernovas and seeding space with the heavy elements that would eventually become planets and people and poetry. Today, our galaxy is more mature, more settled. The spiral arms still glow with star formation, but at a much more sedate pace. Most of the stars now are smaller, redder, more conservative in their energy usage. They're the cosmic equivalent of wise elders, having learned to make their resources last. A red dwarf star, the most common type in our galaxy, can shine steadily for trillions of years, far longer than our universe has existed so far. These red dwarfs will be the last stars standing when the cosmic party finally winds down. Long after our sun has swelled into a red giant and then collapsed into a white dwarf, long after the most massive stars have either exploded or collapsed into black holes, the red dwarfs will continue their patient vigil. They're like the responsible friends who stay behind to clean up after everyone else has gone home. But even these stellar marathoners will eventually run out of fuel. The laws of physics are remarkably patient but utterly inflexible. Every star, no matter how carefully it manages its resources, will eventually burn through its last bit of hydrogen and begin to fade. When that happens, when the final red dwarf dims to darkness, the stelliferous era will officially end, and the universe will enter what cosmologists call the degenerate era. The degenerate era sounds rather ominous, doesn't it? But it's actually named after degenerate matter, the exotic stuff that makes up white dwarf stars and neutron stars. These stellar remnants will dominate this phase of cosmic history, slowly cooling and fading like embers in a dying fireplace. The universe will be darker then, much darker, but not completely lifeless. White dwarf stars, though no longer burning nuclear fuel, will continue to glow for trillions of years simply from their stored heat. Imagine a poker that's been pulled from a fire. It no longer has flames dancing along its length, but it remains warm to the touch for hours afterward. White dwarfs are cosmic pokers, cooling so slowly that they can provide gentle warmth to any planets that might orbit them. During this era, which could last for 10 to the 37 years, that's a 1 followed by 37 zeros, the universe will be a place of profound patience. Occasionally, two white dwarfs might collide, briefly reigniting nuclear fusion and creating a supernova that illuminates a small corner of the cosmos. Brown dwarfs, those failed stars that never quite managed to ignite, might capture wandering planets and heat them through gravitational friction. Even more rarely, a white dwarf might slowly accumulate matter from space dust and cosmic debris until it reaches a critical mass and explodes in what astronomers call a Type Ia supernova. These events will be like distant fireworks in an otherwise quiet night, reminders that the universe still has a few tricks up its sleeve, a few final moments of drama left to perform. But perhaps the most fascinating possibility during the degenerate era involves quantum mechanics and something called quantum tunneling. At the subatomic level, particles can sometimes pass through barriers that should be impossible to cross, like a ball rolling up and over a hill when it doesn't have enough energy to reach the top. Given enough time, and the degenerate era offers plenty of time, quantum tunneling might allow even cold, dead stars to briefly reignite. The probability of this happening to any particular white dwarf is vanishingly small, but multiply that tiny chance by trillions upon trillions of stars and countless eons of time, and eventually the impossible becomes inevitable. Somewhere in the far future, a white dwarf that has been cold and dark for longer than our current universe has existed might suddenly flicker back to life, fusion briefly resuming in its core like a phoenix rising from cosmic ashes. These quantum resurrection events will be extraordinarily rare, perhaps separated by timescales so vast that they beggar the imagination. But they represent something beautiful about the universe's relationship with time and probability. Given enough patience, even the most unlikely events become not just possible, but certain. As the degenerate era slowly fades, the universe will enter an even stranger phase called the black hole era. By this time, most ordinary matter will have either fallen into black holes or been scattered so thinly by cosmic expansion that it might as well not exist. The universe will be dominated by these gravitational monsters, slowly evaporating through Hawking radiation like ice cubes melting in an infinitely patient summer. Stephen Hawking's discovery that black holes emit radiation was one of the most counterintuitive findings in physics. These objects, so dense that not even light can escape their gravitational pull, actually glow with a faint thermal radiation. The smaller the black hole, the hotter its glow, but even the largest black holes in our universe emit this radiation, though so weakly that it would take longer than the current age of the universe for them to lose even 1% of their mass. But time is the one resource the universe has in unlimited supply. During the black hole era, which could last until 10 to the 100 years in the future, these cosmic vacuum cleaners will slowly shrink, evaporating photon by photon back into the quantum foam from which they came. As they shrink, they'll glow brighter and hotter until in their final moments they'll release their remaining energy in a brief flash of gamma rays. Picture a snowman melting in slow motion, so slowly that each drop of water represents millions of years. At first, the melting is imperceptible, but as time passes, the process accelerates. The snowman gets smaller and smaller until finally, with a tiny splash, the last bit of snow becomes water and flows away. Black holes evaporate in much the same way, except their final splash will be a burst of high energy radiation that briefly illuminates whatever remains of the cosmos. When the last black hole finally evaporates, the universe will enter its final phase, sometimes called the dark era or the heat death era proper. This is the cosmic endgame we've been building toward, when the universe achieves maximum entropy and thermal equilibrium. All energy will be spread so evenly throughout space that no work can be done, no complexity can arise, no interesting events can occur. In this far future, the universe will consist primarily of electrons, positrons, neutrinos, and photons, all at nearly the same temperature and scattered throughout an unimaginably vast volume of space. The temperature will be so close to absolute zero that the difference between the warmest and coldest regions could be measured in billionths of a degree. It will be a cosmos of perfect democracy where every particle has exactly the same amount of energy as every other particle. And yet, even in this seemingly barren future, quantum mechanics suggests that extraordinary things might still occasionally happen. Virtual particles will continue to pop in and out of existence, creating tiny fluctuations in the quantum vacuum. Over timescales so vast that they make the black hole era seem brief, these fluctuations might occasionally organize themselves into complex structures, perhaps even conscious observers who wonder about their place in an ancient, cold universe. Some physicists have speculated that given infinite time, quantum fluctuations might eventually recreate any possible arrangement of matter, including exact copies of every moment that has ever existed. Your current experience, reading these words, might happen again in the far future, spontaneously arising from the quantum foam like a dream half remembered upon waking. This idea, sometimes called the Poincare recurrence theorem, suggests that the universe might be cyclical on timescales so enormous that they dwarf even our current estimates of cosmic age. Everything that has happened might happen again and again and again, each iteration separated by periods of darkness so long that entire universes could be born and die in the intervals between repetitions. It's a thought both comforting and unsettling. The idea that this moment, this breath you're taking, This gentle contemplation of cosmic endings might be eternal in ways we can barely comprehend. Perhaps the heat death isn't an ending at all, but simply the longest intermission between acts in an infinitely patient cosmic play. But before we drift too deeply into these vast timescales and quantum possibilities, let's pause to consider something rather remarkable about our current moment in cosmic history. We are living during what might be called the universe's golden age, when complexity has reached its peak and consciousness has emerged to contemplate its own existence. In the grand timeline of cosmic evolution, this is the brief flowering of awareness between the initial chaos of creation and the final silence of heat death. Think of it this way: if the entire future of the universe were compressed into a single year, we would be living in the first few seconds of January 1st. Everything we consider ancient, the formation of our solar system, the evolution of life on Earth, the rise of human civilization, all of it happens in that initial moment of cosmic spring. The remaining 11 months and 30 days stretch ahead in increasingly quiet contemplation as the universe slowly settles into its eternal rest. This perspective might seem to diminish our significance, but I find it does quite the opposite. We are the universe's way of experiencing itself during its most vibrant and creative period. Every thought you think, every emotion you feel, every moment of wonder as you gaze up at the night sky is the cosmos becoming aware of its own magnificent story. You are not separate from the universe. You are the universe, temporarily organized into a pattern complex enough to appreciate beauty, to ponder meaning, to feel love and loss and hope. The atoms in your body were forged in the nuclear furnaces of ancient stars, scattered across space by stellar winds and supernova explosions, then gradually assembled over billions of years into the remarkable biological machine that is you. The calcium in your bones, the iron in your blood, the oxygen you breathe, all of it was created during the universe's most energetic and productive era. You are quite literally made of star stuff, as Carl Sagan so poetically reminded us. And here's something beautiful to consider. The same physical laws that predict the heat death of the universe are the laws that allowed your consciousness to emerge in the first place. The second law of thermodynamics, which dooms the cosmos to increasing entropy and eventual thermal equilibrium, is also what drives the chemical reactions that power your thoughts. The expansion of space that will eventually isolate all galaxies from one another is what created the conditions necessary for stars to form and planets to coalesce. In other words, the universe's journey toward heat death isn't separate from the story of life and consciousness. It's the very same story told from a different perspective. The cosmic cooling that will eventually still all motion is what allowed matter to condense from the primordial fireball. The spreading of energy that will eliminate all temperature gradients is what created the gentle warmth that makes life possible on worlds like ours. This interconnectedness extends beyond the merely physical. Consider how the concept of entropy, that tendency toward disorder and equilibrium, plays out in human experience. We see it in the way a tidy room gradually becomes cluttered, the way a hot cup of tea slowly reaches room temperature, the way even our most cherished memories fade with time. Yet we also witness something miraculous: the emergence of order from chaos, the spontaneous organization of matter into living systems, the creation of beauty and meaning in the face of cosmic indifference. Life, it seems, is the universe's way of creating temporary pockets of decreasing entropy, islands of increasing complexity, in an ocean of spreading disorder. Every time a plant grows, converting sunlight into complex organic molecules, it's fighting against the cosmic tide. Every time a mind learns something new, creating neural pathways and storing information, it's building order in a universe trending toward randomness. But here's the crucial point: this isn't a battle that life wins or loses. It's a dance, a temporary arrangement, a brief flourishing that adds beauty to the cosmic story without changing its ultimate destination. We are like flowers blooming in a field that will eventually be covered by snow. The coming winter doesn't diminish the flower's beauty. If anything, it makes each bloom more precious, more worthy of attention and care. The heat death of the universe, viewed from this perspective, isn't a failure or a tragedy. It's the natural completion of a process that began with the Big Bang and will end with perfect equilibrium. Every star that shines, every planet that forms, every life that emerges is part of this grand unwinding, this gradual transformation of concentrated energy into evenly distributed peace. Scientists have calculated that we're currently living through what they call the universe's adolescence, a time of tremendous activity and change. Star formation rates are declining, but still substantial. Galaxies are colliding and merging, creating spectacular displays of cosmic fireworks. Black holes are growing, but slowly, patiently accumulating matter over millions of years. The cosmic web, that vast network of dark matter filaments connecting galaxies across billions of light years, is still evolving, still drawing matter together into ever larger structures. In perhaps 5 billion years, our own Milky Way will collide with the Andromeda Galaxy in what astronomers call a galactic merger. Despite the dramatic name, this will be a surprisingly gentle process, more like two clouds of fireflies slowly interpenetrating than any violent crash. Most stars will simply find new orbits in the combined galaxy, which some have whimsically dubbed Milkomeda. The night sky will be spectacular during this merger, filled with brilliant new star formation triggered by the gravitational disturbances. But even this cosmic dance is part of the larger pattern of cooling and expansion. After the merger settles down, after the burst of new star formation exhausts the available gas and dust, Milkomeda will become an increasingly quiet place. The spiral arms that give our current galaxy such elegant structure will gradually fade as the stellar populations age and fewer new stars are born to replace those that die. This is happening throughout the universe, a slow transition from the dynamic chaos of youth to the settled wisdom of age. In the far future, the universe will be populated by ancient elliptical galaxies, their spiral structures long since dissolved, their star formation all but ceased. These galactic retirement communities will be dominated by long-lived red dwarf stars and the cooling remnants of more massive stars that burned out eons ago. Yet even in this seemingly quiet future, there will be moments of unexpected drama. Occasionally, two white dwarf stars will spiral into each other, their dance growing faster and faster until they merge in a brilliant Type Ia supernova, briefly outshining an entire galaxy. Sometimes, a wandering star will be captured by a black hole, its matter slowly accreting onto the event horizon and heating up until it glows brighter than 1,000 suns before finally disappearing forever. These events will become increasingly rare as the universe ages and expands, like the final few kernels of popcorn in a nearly empty pot. Each flash of light will illuminate a cosmos grown vast and dark and patient, a reminder of the violence and beauty that once characterized every corner of space. They'll be like distant lightning glimpsed through storm clouds, brilliant but brief, leaving the darkness somehow deeper than before. The mathematics of cosmic evolution tells us that these moments of drama will eventually cease altogether. The last supernova will explode. The last black hole will finish consuming its surroundings, and the universe will settle into the long, slow process of thermal equilibration. This phase will last so long that all the time that has passed since the Big Bang will seem like barely an instant in comparison. During these unimaginable eons, the only significant events will be quantum mechanical in nature. Virtual particles will continue to appear and disappear in the vacuum of space, creating tiny fluctuations that, given enough time, might occasionally organize themselves into larger structures. The probability of any particular fluctuation creating something complex is vanishingly small, but infinity is very patient, and even the most unlikely events become inevitable given sufficient time. Some cosmologists have speculated about what they call Boltzmann brains, spontaneous quantum fluctuations that briefly organize themselves into conscious observers before dissolving back into the vacuum. These hypothetical entities would exist for only moments, experiencing a flash of awareness in an otherwise empty universe before their constituent particles drift apart. It's a strange and somewhat unsettling idea, the notion that consciousness might occasionally flicker into existence in the cosmic dark, like lightning bugs blinking in an infinite summer evening. But perhaps the most beautiful possibility involves what physicists call vacuum metastability. Our current understanding suggests that space itself might exist in what's called a false vacuum, a temporarily stable state that could, given enough time, decay into a lower energy configuration. If this ever happened, it would create a bubble of new physics, expanding at the speed of light, potentially giving birth to an entirely new universe with different physical laws and constants. This process, sometimes called vacuum decay, would be completely unpredictable and might never happen at all. But if it did, it would represent the ultimate recycling program, the universe's way of starting fresh after the heat death has run its course. The old cosmos would be swept away like autumn leaves, making room for new forms of complexity and perhaps new types of consciousness to emerge. It's rather like the way a forest fire, devastating as it seems, actually prepares the ground for new growth. Some seeds can only germinate after being exposed to intense heat, and some ecosystems depend on periodic fires to clear away the accumulated debris of previous generations. Perhaps the universe has its own version of this cycle, with heat death serving not as an ending, but as a preparation for rebirth. Of course, all of this remains highly speculative. We're dealing with timescales so vast and processes so subtle that our current physics can only offer educated guesses about what might unfold. The universe has already surprised us many times, from the discovery of cosmic acceleration to the realization that most of reality consists of dark matter and dark energy that we barely understand. There may be phenomena awaiting discovery that could completely change our understanding of cosmic destiny. But regardless of the specific details, the general pattern seems clear. The universe began in a state of tremendous energy concentration and has been spreading that energy thinner and thinner ever since. This process has allowed for the emergence of incredible complexity and beauty, but it's ultimately a one way journey toward equilibrium and rest. And perhaps that's as it should be. The universe has given us nearly 14 billion years of cosmic evolution, billions of worlds where life might flourish, countless opportunities for consciousness to emerge and contemplate its own existence. Every sunset you've ever watched, every piece of music that moved you to tears, every moment of love or wonder or simple contentment is part of this grand cosmic gift. The heat death, when it finally arrives in the unimaginably distant future, will be like the universe finally laying down to rest after the longest and most productive day imaginable. It will have created stars and planets, chemistry and biology, minds and hearts and souls. It will have given rise to creatures capable of mathematics and poetry, of laughter and tears, of looking up at the night sky and feeling both infinitely small and cosmically connected. In that final moment of thermal equilibrium, when the last temperature gradient disappears and the last bit of useful energy is exhausted, the universe will achieve something remarkable: perfect peace. No more struggle, no more change, no more the restless churning that has driven cosmic evolution for billions of years. Just stillness, silence, and the profound satisfaction of a story well told. And yet, as we contemplate this cosmic finale, there's something rather extraordinary happening in the present moment. While the universe slowly unwinds toward its peaceful conclusion, complexity continues to flourish in the most unexpected ways. Think of it as watching a candle burn in a gentle evening breeze. The wax gradually diminishes, the flame flickers and dances. But for now, in this moment, it casts the most beautiful warm light across everything around it. We are living during what cosmologists sometimes call the Goldilocks epoch, when conditions in the universe are not too hot, not too cold, but just right for the emergence of intricate structures and perhaps most remarkably, conscious observers who can ponder their own existence. It's a delicate balance, this moment between the initial chaos of creation and the final silence of equilibrium. Consider how improbable your existence truly is. The early universe was far too hot and dense for complex chemistry to occur. Atoms themselves couldn't form until the cosmos had cooled for nearly 400,000 years. Before that, it was all just a plasma soup of particles zipping about at tremendous speeds, like trying to build a house of cards in a hurricane. Too much energy, too much motion, too much chaos for anything interesting to stick together. On the other end of the timeline, in the far future when heat death approaches, the universe will be too cold and sparse for new complexity to arise. The energy gradients necessary to drive chemical reactions will have long since flattened out. It will be like trying to light a fire with matches that have been soaked in water for centuries. All the ingredients might still be there, but the spark, the driving force, will be gone. But here, in this cosmic middle ground, we find ourselves in a universe that's perfectly calibrated for wonder. Stars shine with steady light for billions of years, providing the stable energy source that life requires. Heavy elements forged in stellar cores and scattered by supernova explosions accumulate on planetary surfaces, creating the rich chemistry that makes biology possible. Gravity pulls matter together into planets and solar systems, while the expansion of space ensures that these cosmic neighborhoods don't collapse in on themselves. It's rather like being at a dinner party that's reached that perfect moment when everyone has arrived. The conversation is flowing beautifully, and nobody's quite ready to go home yet. The party began hours ago with awkward introductions and scattered conversations, and it will end eventually with empty glasses and fond farewells. But right now, in this sweet spot, everything feels possible. The remarkable thing about our cosmic era is how it manages to balance creation and destruction in the most elegant dance imaginable. Stars are born in stellar nurseries where gravity gently coaxes gas clouds into ever denser knots until nuclear fusion ignites, like cosmic flowers blooming in slow motion across millions of years. At the same time, other stars reach the end of their lives, some swelling into red giants that engulf their planets, others exploding in supernovae that briefly outshine entire galaxies. This stellar life cycle creates what astronomers call the cosmic recycling program. The hydrogen and helium forged in the Big Bang get processed through stellar furnaces, emerging as carbon, oxygen, silicon, iron, and all the other elements that make rocky planets and living creatures possible. When these stars die, they scatter their enriched contents back into space, seeding the next generation of stars and worlds with ever more complex chemistry. Your body is a testament to this cosmic recycling. The calcium in your bones was forged in the nuclear fires of massive stars that died billions of years ago. The iron in your blood was created when those stars collapsed and exploded, scattering their contents across light years of space. The oxygen you breathe came from stellar winds and supernova shock waves that enriched the interstellar medium with life giving elements. In a very real sense, you are the universe contemplating itself. Every thought you think is cosmic matter, organized in such an exquisite way that it has become self aware. The same atoms that once drifted in the cold emptiness between stars are now reading these words, following these ideas, perhaps feeling a sense of wonder at the sheer improbability of it all. This perspective transforms our understanding of what it means to be human in a cosmos destined for heat death. We're not separate from the universal story. We're one of its most beautiful chapters. The same physical processes that will eventually lead to thermal equilibrium are the ones that allowed your consciousness to emerge in the first place. The expansion of space that will ultimately isolate all galaxies created the conditions for stellar nucleosynthesis. The cooling of the universe that will eventually still all motion is what allowed atoms to form and chemistry to begin. Scientists have calculated that we're living during peak complexity in cosmic history. Never before have there been so many different types of structures coexisting in the universe, from subatomic particles to galaxy clusters spanning hundreds of millions of light years. Never again will there be such a rich tapestry of phenomena, such a symphony of interactions across so many scales of space and time. The diversity is breathtaking when you really contemplate it. In stellar cores, hydrogen nuclei slam together at temperatures of millions of degrees, fusing into helium and releasing the energy that makes stars shine. In the frigid depths of space, organic molecules drift between the stars, slowly growing more complex through chemical reactions that unfold over millions of years. On planetary surfaces, liquid water carves canyons and deposits minerals, creating the geological foundations for potential life. And then there's biology, that most improbable flowering of cosmic complexity. From the first self replicating molecules that emerged in some ancient tide pool to the vast networks of neural connections that generate human consciousness, life represents the universe's most ambitious experiment in organization and information processing. Consider the elegant solutions that evolution has discovered, the way chlorophyll captures sunlight and converts it into chemical energy, essentially eating starlight to power the chemistry of life. The way DNA stores information in a molecular library so compact that all the genetic instructions for a human being can fit inside a microscopic cell nucleus. The way neurons form networks that can not only process sensory information but create art, compose music, and ponder the meaning of existence. Each of these biological innovations required millions of years to develop and fine tune. They represent solutions to problems that would challenge our most sophisticated engineers, yet they emerge through the patient trial and error of natural selection, guided only by the simple principle that what works gets passed on to the next generation. But perhaps the most remarkable achievement of this cosmic complexity is consciousness itself. Somehow, through processes we still don't fully understand, the universe has organized matter in such a way that it can experience itself subjectively. You don't just process information like a computer. You have inner experiences, subjective feelings, a sense of being someone rather than just something. This consciousness allows you to step outside the immediate flow of cause and effect and contemplate larger patterns and meanings. You can imagine the past, anticipate the future, and even conceive of concepts like heat death that won't become relevant for trillions of years. In a universe trending toward equilibrium and simplicity, minds like yours create pockets of meaning and purpose that shine like beacons in the cosmic dark. The timing of this conscious awakening is particularly poignant. We've its peak emerged just as the universe reaches the most to observe and understand. We of structural complexity, when there can look out at galaxies whose dust for billions of years, seeing the light has been traveling toward cosmos as it was when it was younger and more chaotic. We can peer into the hearts of stars with our telescopes and understand the nuclear processes that power them. We can even detect the faint afterglow of the Big Bang itself, that cosmic microwave background that fills all of space with ancient light. At the same time, we can look forward and use our understanding of physics to predict the universe's future. We know that our sun will gradually brighten over the next billion years, eventually making Earth too hot for life. We can calculate when the Milky Way will collide with Andromeda, and we can extrapolate the timeline of stellar evolution all the way to the era when the last red dwarf finally fades to darkness. This dual perspective, looking backward to cosmic origins and forward to ultimate destinations, gives our species a unique role in the universal story. We are the universe's way of understanding its own biography, of appreciating both its magnificent past and its peaceful future. Through science and mathematics, art and poetry, we create meaning from the raw materials of physics and chemistry. The fact that we can conceive of heat death, that we can understand entropy and thermodynamics well enough to predict the cosmos's ultimate fate, is itself a kind of triumph over that fate. Even if the universe is destined for thermal equilibrium, consciousness has emerged to bear witness to the journey, to find beauty in the process, to create temporary islands of purpose and wonder. And what islands they are! Every human culture has looked up at the night sky and created stories to explain what they saw. Every civilization has developed mathematics and philosophy, art and music, ways of making sense of existence that go far beyond mere survival. These cultural achievements are as much a part of cosmic evolution as the formation of stars or the synthesis of heavy elements. When you listen to a piece of music that moves you deeply, you're experiencing the universe's capacity for beauty made manifest in sound waves and neural patterns. When you feel compassion for another person, you're witnessing cosmic matter that has organized itself to the point where it can care about other arrangements of cosmic matter. When you contemplate the heat death of the universe with a sense of melancholy wonder, you're participating in the cosmos's own contemplation of its destiny. This perspective doesn't diminish the reality of entropy or change the ultimate trajectory toward thermal equilibrium. The second law of thermodynamics remains as unforgiving as ever, and the universe will continue its slow journey toward maximum entropy, regardless of what we think or feel about it. But it does suggest that meaning and purpose aren't absent from the cosmic story. They're woven into its very fabric, emerging naturally from the same physical processes that govern stellar evolution and galactic dynamics. In the grand timeline of the universe, conscious observers like us exist for only the briefest moment. If cosmic history were compressed into a single day, complex life would appear in the final few minutes, and human civilization would flash into existence in the last fraction of a second. Yet in that tiny interval, the universe achieves something extraordinary. It becomes aware of itself. This awareness carries with it a kind of responsibility. We are the cosmos's memory keepers, the ones who can look back at 14 billion years of cosmic evolution and appreciate its beauty and complexity. We are also its storytellers, the ones who can imagine what lies ahead in those unimaginable eons when the last stars fade and the universe settles into its final rest. Perhaps that's enough. Perhaps the fact that the universe gave rise to consciousness, even briefly, even in this tiny corner of space and time, represents a kind of victory over entropy. Not a permanent victory, certainly, but a meaningful one nonetheless. Like a single candle lit in a vast cathedral, consciousness may be small and temporary, but it illuminates everything around it and makes the darkness somehow less absolute. The heat death still approaches, patient and inevitable, but it no longer seems quite so bleak. It's simply the universe's way of completing its story, of reaching the peaceful conclusion toward which it has been slowly moving since the first moment of creation. And we, the temporary arrangements of matter that have learned to think and feel and wonder, are privileged to witness this cosmic journey and find meaning in both its magnificent complexity and its ultimate simplicity. As we drift deeper into contemplation of these vast timescales and cosmic destinies, it's worth pausing to consider what this knowledge means for how we live our daily lives. After all, what difference does it make that the universe will eventually reach thermal equilibrium in some unimaginably distant future. How should the prospect of heat death influence the way we treat each other, the way we pursue happiness, the way we find meaning in our brief existence? The answer, I think, is both everything and nothing at all. On one hand, the cosmic perspective reminds us that all our earthly concerns, all our petty disagreements, and temporary troubles are vanishingly small when viewed against the backdrop of universal history. Your mortgage payments and traffic jams, your career anxieties and social media disappointments, all of it fades into insignificance when you contemplate the birth and death of stars. This can be profoundly liberating. Many of the things we worry about simply don't matter on any meaningful timescale. The embarrassing thing you said at a dinner party last week will be forgotten long before our sun begins its transformation into a red giant. The political crisis that dominates today's headlines will be ancient history before the Milky Way completes even one more rotation around its center. From this cosmic vantage point, it becomes easier to let go of grudges, to forgive others their small failures, to approach life with a sense of humor and humility. We're all just temporary patterns in the cosmic dance, brief arrangements of stardust that have somehow learned to love and laugh and dream. Our individual stories may be fleeting, but they're part of something much larger and more beautiful than any of us can fully comprehend. On the other hand, the knowledge that consciousness is rare and temporary in the cosmic scheme makes every moment of awareness more precious, not less. The fact that you can read these words, that you can contemplate the heat death of the universe while feeling the warmth of sunlight on your skin or the comfort of a soft chair, is an extraordinary privilege that most of the matter in the cosmos will never experience. This should inspire not despair, but a deep appreciation for the gift of existence. Every sunset is more beautiful when you understand that it's powered by nuclear fusion in a star that will shine for only a few billion more years. Every human relationship becomes more meaningful when you realize that consciousness is the universe's way of knowing itself, and that the love you feel for others is cosmic matter caring about cosmic matter in the most improbable and wonderful way. The heat death of the universe doesn't make life meaningless. It makes life incredibly, almost impossibly meaningful. In a cosmos trending toward equilibrium and simplicity, every moment of complexity and beauty is a small miracle. Every act of kindness is the universe being kind to itself. Every instance of wonder, or joy, or love is reality celebrating its own extraordinary creativity. This perspective can transform how we think about time and mortality. Yes, our individual lives are brief when measured against cosmic timescales, but they're also unique and irreplaceable. The particular arrangement of atoms that makes up your consciousness has never existed before and will never exist again. Your thoughts, your memories, your way of seeing the world, all of it is a one-time only performance in the cosmic theater. When you look up at the night sky and feel that sense of connection to something larger than yourself, you're not imagining things. You really are connected in the most literal and fundamental way possible. The atoms in your body were forged in stellar cores. The energy powering your thoughts came originally from the Big Bang, and the very capacity for awareness that allows you to contemplate these ideas is the universe's own gift to itself. This connection extends beyond the merely physical. Every human culture has developed ways of finding meaning and purpose that transcend individual survival. We create art that will outlast us. We seek truth that illuminates not just our own lives, but the lives of future generations. We love not just our immediate family, but abstract concepts like justice and beauty and the welfare of people we'll never meet. These seemingly irrational behaviors make perfect sense when viewed from the cosmic perspective. We are the universe's way of creating meaning, of finding purpose in the dance between order and entropy. Our drive to understand, to create, to care about things larger than ourselves is cosmic evolution, expressing itself through conscious beings who can appreciate both the journey and the destination. The knowledge of heat death can even deepen our sense of wonder rather than diminishing it. When you understand that the complexity you see around you, the intricate ecosystems and weather patterns and geological formations, all of it represents a temporary victory over entropy, it becomes more beautiful, not less. The fact that such extraordinary organization can emerge from simple physical laws, even temporarily, is one of the most amazing discoveries in all of human history. This is why science, far from robbing the universe of mystery and meaning, actually reveals just how mysterious and meaningful it truly is. The more we learn about cosmic evolution, about the delicate balance of forces that allows complexity to flourish, about the improbable emergence of consciousness from unconscious matter, the more reasons we find for awe and gratitude. Even the concept of heat death itself, properly understood, is more beautiful than terrifying. It represents the universe's ultimate achievement of perfect justice and equality, a state where every particle has exactly the same amount of energy as every other particle, where there are no more rich and poor regions of space, no more hot and cold, no more inequality of any kind. It's the cosmic equivalent of perfect peace, the end of all struggle and competition and conflict. In that far future, when the last black hole has evaporated and the universe has achieved maximum entropy, there will be a kind of ultimate democracy of matter and energy. Every electron will be equal to every other electron. Every photon will carry exactly the same minuscule amount of energy as every other photon. It will be a cosmos without hierarchy, without exploitation, without suffering of any kind. Of course, it will also be a cosmos without consciousness to appreciate this perfect equality, without minds to contemplate the beauty of such complete symmetry. But perhaps that's as it should be. Perhaps consciousness is meant to be temporary, a brief flowering of awareness that allows the universe to know and appreciate itself during its most creative and complex phase, before settling into the peaceful rest it has earned through billions of years of cosmic evolution. This view suggests that our role as conscious observers is not to prevent heat death or to rage against entropy, but to serve as the universe's witnesses and storytellers. We are here to notice the beauty, to understand the science, to create art and music and poetry that celebrates the extraordinary journey from Big Bang to heat death. We are the cosmos's way of appreciating its own magnificent complexity before that complexity fades into simplicity. And perhaps, in some sense, this witnessing and storytelling is itself a form of immortality. The heat death may eventually erase all trace of stars and planets and living things, but the meaning we create, The understanding we achieve, the love we share becomes part of the universal story in a way that transcends mere physical existence. Every moment of consciousness adds something irreplaceable to the cosmic narrative, a unique perspective that enriches the total sum of what it means for reality to exist. So, as we continue our gentle journey toward understanding the universe's ultimate destiny, let's carry with us not fear or despair, but wonder and gratitude. We are living during the universe's golden age of complexity and creativity, when the cosmic dance between order and entropy has reached its most elaborate and beautiful expression. We get to be part of that dance, to add our own steps to the choreography, to contribute our own voices to the cosmic song. The heat death still awaits in the unimaginably distant future, patient and inevitable as ever. But between now and then lies an eternity of moments to appreciate, of mysteries to explore, of connections to make with other conscious beings who share our privilege of awareness. In the grand story of the universe, we may be just a brief chapter, but what a magnificent chapter it is, full of wonder and discovery and the deep satisfaction of a cosmos that has learned to know and love itself. The mathematics of this cosmic ending are surprisingly gentle when you really examine them. Unlike the dramatic scenarios that once dominated cosmological thinking, violent collapses, or catastrophic rips in the fabric of space itself, heat death unfolds with the patience of a master storyteller who knows that the most profound endings require time to develop their full meaning. Consider the elegance of how energy dissipates through the universe. It follows what physicists call the principle of least action, always choosing the path that requires the minimum expenditure of effort. Like water finding its way downhill, energy naturally flows from regions of high concentration to low, from hot to cold, from organized to scattered. But unlike water, which eventually reaches the ocean and stops, cosmic energy spreads through an ever expanding space that grows larger every moment. This expansion is crucial to understanding why heat death is inevitable rather than merely probable. In a static universe, one that neither expanded nor contracted, there might be cycles of concentration and dispersal, eternal rhythms of gathering and scattering that could continue indefinitely. But our universe is not static. Space itself is growing, carrying galaxies apart like seeds scattered by an ever strengthening wind. The discovery of this expansion was one of the most profound shifts in human understanding of cosmic destiny. Before Edwin Hubble peered through his telescope and noticed that distant galaxies were fleeing from us, scientists imagined a universe that was essentially unchanging on the largest scales. Stars might be born and die, planets might form and crumble, but the overall structure of the cosmos seemed eternal and stable. Albert Einstein himself was so committed to this vision of cosmic permanence that he introduced a mathematical fudge factor, the cosmological constant, into his equations of general relativity to prevent the universe from either expanding or contracting. When Hubble's observations revealed that expansion was actually occurring, Einstein reportedly called this cosmological constant his greatest blunder, though modern discoveries about dark energy suggest he may have been more prescient than he realized. The expanding universe changes everything about cosmic fate. In a static cosmos, gravity might eventually pull all matter back together, creating cycles of expansion and contraction that could theoretically continue forever. But in an expanding universe, especially one where that expansion is accelerating, gravity loses the cosmic tug of war. Matter gets carried apart faster than gravitational attraction can pull it back together. This cosmic stretching has profound implications for the distribution of energy. Imagine trying to heat a room where the walls are constantly moving outward. No matter how powerful your heater, the expanding volume means that any warmth you generate gets diluted across an ever larger space. This is precisely what's happening to the universe on the grandest scale. The energy that once filled a space smaller than an atom is now spread across billions of light years, and that spreading continues with each passing moment. But the expansion itself tells only part of the story. The other crucial factor is what cosmologists call the arrow of time, the fundamental asymmetry that makes the universe's past different from its future. This arrow points relentlessly toward increasing entropy, toward greater disorder and more even distribution of energy. You can see this arrow operating in the simplest, everyday phenomena. Drop a glass and it shatters into pieces, but those pieces never spontaneously reassemble themselves into a whole glass. Burn a piece of paper and it turns to ash and smoke, but ash and smoke never reorganize themselves back into paper. Mix cream into coffee and the two liquids blend together, but they never separate back into distinct layers. These examples might seem trivial compared to the grand cosmic processes we've been discussing, but they're all manifestations of the same fundamental principle that governs the universe's ultimate destiny. The second law of thermodynamics, that inexorable tendency toward increasing entropy, operates at every scale from coffee cups to galaxy clusters. What makes this principle so powerful is that it's not just a human observation about how things tend to behave. It's a mathematical certainty built into the very structure of reality. There are vastly more ways for energy to be disorganized than organized, just as there are vastly more ways to arrange a deck of cards randomly than in any specific order. Given enough time and enough opportunities for change, the universe naturally evolves toward the most probable state, which is maximum entropy. This statistical inevitability is both beautiful and melancholy. It means that the current moment, with its rich complexity and intricate structures, represents an extraordinarily improbable arrangement of matter and energy. Every star, every planet, every living creature is a temporary victory over the cosmic tendency toward disorder, a brief flowering of organization in an ocean of increasing randomness. The timescales involved in this cosmic evolution are so vast that they challenge our ability to truly comprehend them. When scientists talk about the heat death occurring in 10 to the 100 years, they're describing a number so large that it dwarfs every other quantity in human experience. If you wrote out this number in ordinary decimal notation, it would require more digits than there are atoms in the observable universe. To put this in perspective, imagine that every atom in your body represents 1 year. The total number of atoms in all the people who have ever lived would still be infinitesimally small compared to the time remaining before heat death. It's a span so enormous that entire universes could be born, evolve complex civilizations, and fade away in what would amount to barely a moment in the cosmic timeline. During this almost infinite stretch of time, extraordinary things will occasionally happen through sheer statistical chance. Quantum mechanics tells us that even the most unlikely events become inevitable given sufficient opportunities. Virtual particles that normally appear and disappear in microscopic fractions of a second might, through quantum tunneling, occasionally persist long enough to interact with other particles and create brief moments of complexity in an otherwise simple cosmos. These quantum fluctuations might even occasionally organize themselves into structures that resemble the complexity we see today. The probability is vanishingly small, but infinity is very patient. Somewhere in the unimaginably distant future, random quantum events might briefly recreate something resembling a star, a planet, perhaps even a pattern complex enough to constitute a moment of awareness before dissolving back into the quantum foam. Some physicists have suggested that these quantum resurrections might be indistinguishable from the original phenomena they mimic. A consciousness that emerges from quantum fluctuations in the far future might experience itself as completely real and continuous with its past, even though that past would be purely coincidental, a random arrangement of particles that happens to encode memories of events that never actually occurred. This possibility raises profound questions about the nature of identity and continuity. If quantum mechanics can occasionally recreate any possible arrangement of matter, including exact duplicates of your current brain state, what does it mean to say that you exist only once? Perhaps every moment of consciousness that has ever occurred will be repeated countless times in the quantum lottery of the far future, each iteration as real and valid as the original. These ideas venture into territory that borders on philosophy as much as physics, but they illustrate something important about our cosmic destiny. Even in the face of heat death, even in a universe trending inexorably toward maximum entropy, the fundamental creativity of quantum mechanics ensures that the story never truly ends. It simply becomes increasingly sparse, increasingly patient, increasingly subtle. The beauty of this quantum creativity lies partly in its complete unpredictability. Unlike the regular cycles of stellar birth and death that characterize our current cosmic era, the far future will be governed by pure chance. No one can predict when or where the next quantum fluctuation will create a momentary island of complexity. Each event will be a complete surprise, a gift from the mathematical structure of reality itself. This unpredictability extends to the possibility of vacuum decay, that hypothetical process by which space itself might transition to a lower energy state. If such an event ever occurs, it would create a bubble of new physics expanding at light speed, potentially erasing everything in its path while simultaneously creating conditions for entirely new forms of complexity to emerge. The metaphor that comes to mind is of a vast library slowly burning down. Most of the books are being consumed by the flames of entropy, their information content gradually turning to ash and smoke. But occasionally, a spark from one burning volume might ignite a new flame somewhere else, briefly illuminating pages that contain entirely different stories, written in languages that haven't been invented yet. Current observations suggest that our universe exists in what physicists call a metastable vacuum state. This means that space itself, despite appearing empty, actually contains a certain amount of energy that might not represent the absolute minimum possible. If a lower energy state exists, and if quantum fluctuations ever trigger a transition to that state, the results would be catastrophic for our current form of reality, but potentially creative for whatever comes next. The probability of such vacuum decay is thought to be extraordinarily small, so small that it might never happen despite the vast timescales available. But like all quantum processes, it becomes more likely as time passes, simply because there are more opportunities for the improbable transition to occur. It's another reminder that even our most fundamental assumptions about the stability of physical law might be temporary, subject to change on timescales that make the heat death itself seem rushed. These possibilities transform our understanding of what cosmic endings mean. Rather than viewing heat death as a final termination, we might see it as a transition to a different kind of existence, one governed by quantum creativity rather than classical physics. The universe might not end so much as transform, shedding its current identity like a snake molting its skin. This perspective suggests that consciousness itself might have a more enduring role in cosmic evolution than we previously imagined. If quantum fluctuations can recreate any possible arrangement of matter, including the neural patterns that constitute awareness, then consciousness might be truly eternal, appearing and disappearing like waves on an infinite ocean, but never permanently absent from reality. The implications are both humbling and inspiring. Every thought you think, every moment of wonder or love or simple contentment might echo through eternity in ways you'll never know. The quantum lottery of the far future might occasionally deal cards that recreate not just your physical brain, but your entire subjective experience, complete with memories and personality and the peculiar sense of being yourself rather than someone else. In this view, the heat death of the universe becomes less like an ending and more like a vast intermission, a cosmic rest period between acts in an infinitely long play. The current act, with its stars and galaxies and living creatures, will eventually conclude, but the theater itself will remain open, occasionally hosting new performances that spring from the pure creativity of quantum mechanics. This doesn't change the immediate trajectory toward thermal equilibrium, nor does it alter the mathematical certainty that our current cosmic era will eventually end. But it does suggest that endings might be more nuanced than we initially imagined, that the universe's capacity for surprise extends even into realms where classical physics predicts only silence and darkness. As we contemplate these quantum possibilities dancing at the edge of forever, it's worth remembering that they emerge from the same mathematical framework that describes the heat death itself. The uncertainty principle that allows virtual particles to borrow energy from the vacuum is the same principle that governs radioactive decay and stellar fusion. The wave functions that might occasionally collapse into complex structures are described by the same equations that predict atomic behavior in your morning coffee. This unity of physical law across all scales and timescales is perhaps the most beautiful aspect of modern cosmology. The same principles that explain why your breath fogs a cold window also determine the ultimate fate of galaxy clusters. The same quantum mechanics that makes computer chips possible also governs the far future resurrection of consciousness from the vacuum of space. We live in a universe where the very small and the very large, the immediate and the eternal, are all connected by threads of mathematical elegance, that we're only beginning to understand. Every equation that describes particle physics also has something to say about cosmic destiny. Every observation of distant galaxies teaches us something about the quantum fluctuations in our own laboratory experiments. This interconnectedness means that studying the heat death of the universe isn't just an exercise in cosmic speculation. It's a way of understanding the fundamental nature of reality itself, the deep principles that govern everything from the formation of atoms to the evolution of consciousness. The universe's journey toward thermal equilibrium illuminates the relationship between information and energy, between order and chaos, between possibility and actuality. And perhaps most remarkably, it reveals that we are not separate observers watching the cosmic story unfold from some external vantage point. We are characters in that story, temporary arrangements of matter and energy that have become complex enough to contemplate the plot in which we're embedded. Our thoughts about heat death are the universe thinking about its own destiny, using brains built from recycled stellar materials to ponder questions that span from the quantum scale to the cosmic horizon. This reflexivity, this capacity for self awareness and self contemplation, might be the most extraordinary phenomenon in all of cosmic evolution. In a universe trending toward simplicity and equilibrium, consciousness represents the emergence of something that can appreciate complexity, that can find meaning in the dance between order and entropy, that can love the very process of existence even while understanding its temporary nature. The heat death of the universe, viewed from this perspective, becomes not just a physical prediction, but a profound meditation on the nature of meaning itself. What does it mean for conscious beings to exist in a cosmos destined for thermal equilibrium? How should the knowledge of our ultimate cosmic fate influence the way we live our brief lives? What responsibilities, if any, do we have as the universe's temporary representatives of awareness and understanding? These questions don't have simple answers, but they point towards something important about our role in the cosmic story. We are not just passive witnesses to the universe's journey toward heat death. We are active participants, creating meaning and beauty and understanding that adds something irreplaceable to the total sum of what it means for reality to exist. Every moment of consciousness, every act of love or creativity or wonder is the universe celebrating its own extraordinary capacity for complexity and self awareness. The profound questions we've been exploring lead us naturally to consider what consciousness might experience during the universe's long twilight. As we drift deeper into these cosmic timescales, there's something almost meditative about contemplating awareness itself in a cooling cosmos, like watching the last embers of a campfire slowly fade while still feeling their gentle warmth. Imagine consciousness as it might exist in the far future when the universe has grown vast and cold and patient. The neural networks that generate your thoughts today rely on the steady flow of energy through biological systems, the constant dance of electrical impulses across synapses, the delicate chemistry of neurotransmitters crossing microscopic gaps between cells. All of this requires energy gradients, temperature differences, the kind of thermodynamic disequilibrium that becomes increasingly rare as the cosmos approaches heat death. But consciousness might find other ways to manifest itself during those unimaginably distant eons. Perhaps awareness could emerge from the quantum fluctuations we discussed, brief moments when random chance arranges matter in patterns complex enough to support thought. These quantum minds might experience existence very differently than we do, their thoughts unfolding over timescales that make our entire civilization seem like a single heartbeat. Picture a consciousness that experiences one thought every trillion years, its neural patterns encoded in the gentle drift of particles through the cosmic dark. To such a mind, the heat death process itself might feel rapid, like watching a time lapse video of cosmic evolution compressed into moments. What seems to us like an eternity of gradual cooling might to these patient observers unfold as a brief but beautiful transformation. The subjective experience of time is, after all, relative to the observer. A mayfly lives its entire life in what we perceive as a single day, yet from the mayfly's perspective, that day contains a full lifetime of experiences, relationships, and perhaps even a form of meaning we can barely imagine. Similarly, these quantum consciousnesses of the far future might pack entire universes of subjective experience into what we calculate as vast stretches of objective time. There's something oddly comforting about this possibility. It suggests that even as the universe settles into thermal equilibrium, even as the last conventional forms of complexity fade away, awareness might persist in forms so subtle and patient that they transform emptiness into fullness, silence into song. The heat death might not eliminate consciousness so much as refine it, distilling it down to its most essential elements, the universe, to end. If consciousness can emerge from quantum fluctuations, if awareness can exist in forms, consider how this changes our understanding of what it means, for we haven't yet imagined, then the heat death becomes a venue. The cosmic theater doesn't close. It simply hosts less like a final curtain and more like a different kind of performance, one that unfolds according to quantum rather than classical rules. This quantum consciousness might experience something we could call cosmic lucid dreaming, aware that it exists within a universe that has achieved maximum entropy, yet still capable of creating meaning and beauty from the mathematical structure of reality itself. Just as you might realize you're dreaming while still remaining immersed in the dream's narrative, these far future minds might understand their quantum nature while still experiencing their thoughts as real and meaningful. The memories of such consciousnesses would be particularly fascinating to contemplate. If quantum fluctuations can recreate any possible arrangement of matter, including neural patterns that encode memories of events that never actually occurred, then these minds might remember entire histories that are purely coincidental. They might have vivid recollections of stars and planets, of love and loss, of civilizations rising and falling, all of it randomly generated by the quantum lottery, yet experienced as completely authentic. In a sense, these quantum memories might be more real than our own. Our recollections are filtered through the limitations of biological memory systems, distorted by emotion and time, incomplete, and sometimes inaccurate. But a consciousness that emerges from quantum fluctuations might have perfect recall of its randomly generated past, experiencing fictional histories with a clarity and immediacy that surpasses anything we can achieve. This raises quantum consciousness, remembers a beautiful, profound questions about the relationship between truth and meaning. If a sunset that never actually occurred, is that memory somehow less valuable than your recollection of a real sunset you watched last week? Both are patterns of information encoded in physical systems. Both generate subjective experiences of beauty and meaning. The only difference is the causal history of how those patterns came to exist. Perhaps this suggests that meaning doesn't depend on historical accuracy, but on the capacity for experience itself. A consciousness that finds beauty in randomly generated memories is creating something genuine and valuable, regardless of whether those memories correspond to actual events. The universe's gift isn't just the ability to remember things that happened, but the ability to find significance in any pattern of information, real or imagined. The social dimensions of these quantum consciousnesses would be equally intriguing. Occasionally, random fluctuations might create multiple minds simultaneously, beings who could interact with each other for brief moments before dissolving back into the vacuum. Thus, chance encounters would be like cosmic ships passing in the night, fleeting connections between islands of awareness in an ocean of emptiness. The conversations between such minds would have a poignancy we can barely imagine. They would know with mathematical certainty that their interaction is temporary, that they will soon return to the quantum foam from which they emerged. Yet they might still find ways to share thoughts, to create art, to experience the peculiar joy of consciousness, recognizing itself in another being. Their entire relationship might unfold and conclude in what we would measure as microseconds, yet subjectively feel like a lifetime of connection. These quantum civilizations might develop forms of culture and meaning that are utterly alien to our experience, yet recognizably conscious in their creativity and self awareness. They might create music from the resonance patterns of virtual particles, write poetry in the mathematical relationships between fluctuating fields, find love in the temporary synchronization of their quantum states. The physics and contemplate it. The same uncertainty principle that prevents underlying these possibilities becomes almost mystical when you really us from knowing both the position and momentum of a particle with perfect precision also ensures that the vacuum of space is never truly empty. Virtual particles constantly appear and disappear, borrowing energy from the future and paying it back so quickly that the debt goes unnoticed by the cosmic accounting system. But occasionally, very occasionally, the books might not balance quite so neatly. A quantum fluctuation might persist a little longer than usual, might interact with other fluctuations in just the right way to create something more complex and enduring. These are the seeds from which quantum consciousness might bloom, moments when the universe's creative bookkeeping accidentally generates awareness. The mathematics of these processes is strangely beautiful, full of equations that describe not just what will happen, but what might happen, probability distributions that span impossible ranges of possibility and impossibility. Quantum mechanics doesn't just tell us that consciousness could emerge from the vacuum, it tells us exactly how likely such emergence is and how long we might have to wait for it to occur. The waiting times are staggering, numbers so large that they make the current age of the universe seem like barely an instant. But the universe has learned patience over its long journey toward thermal equilibrium. It has already waited nearly 14 billion years for consciousness to emerge once. It can wait quadrillions of times longer for consciousness to emerge again. This patience is perhaps the universe's most remarkable quality. Unlike human systems that break down when pushed beyond their limits, cosmic processes seem to have an infinite capacity for endurance. The expansion of space continues without fatigue. The decay of particles proceeds without haste. The approach to thermal equilibrium unfolds with the steady rhythm of a cosmic meditation. In this context, the heat death begins to feel less like an ending and more like a transformation into something we might call cosmic enlightenment. The universe will have learned, through billions of years of evolution, to find peace in simplicity, meaning in emptiness, beauty in the pure mathematical relationships that govern quantum fluctuations. It will have achieved a kind of perfect mindfulness, present in each moment, without grasping for complexity or resisting entropy. The consciousness that emerges during this era might partake of this cosmic enlightenment, experiencing awareness without attachment, thought without suffering, existence without the desperate struggle for survival that characterizes life in our current epoch. These quantum minds might know a kind of peace that we can barely imagine, consciousness that has been refined by eons of cosmic evolution into something approaching pure understanding. Yet they would still be recognizably conscious, still capable of wonder and creativity, and the peculiar joy of existing rather than not existing. The heat death doesn't eliminate these possibilities. It simply provides a different context for them to unfold. Like a master calligrapher who can create beauty with the simplest brushstrokes, the universe of maximum entropy might discover that consciousness requires far less complexity than we imagine. This vision transforms our understanding of what we mean when we speak of the universe's death. Death implies not just ending, but the cessation of all possibility, the final closure of every door. But quantum mechanics suggests that doors never close completely. That possibility always remains, however faintly, however patiently distributed across vast reaches of space and time. The universe approaching heat death might be more like a person entering a deep meditative state, withdrawing from active engagement with the world, but not ceasing to exist. Consciousness might still flicker occasionally in this cosmic meditation, brief moments of awareness arising spontaneously from the mathematical substrate of reality itself. These moments would be gifts beyond measure, instances when the universe briefly awakens from its thermal equilibrium to experience itself once again. They would carry within them the memory of all that came before, the entire history of cosmic evolution encoded in quantum patterns that emerge from pure chance, yet feel as real and meaningful as any experience we've ever had. And perhaps, in some sense, they would be us. If quantum fluctuations can recreate any possible arrangement of matter, if consciousness can emerge from the vacuum through sheer statistical inevitability, then the boundaries between past and future, between original and copy, between self and other, begin to blur in the most beautiful way. The you that is reading these words right now might be just such a quantum fluctuation, a temporary arrangement of particles that has emerged from the far future's cosmic meditation to briefly experience existence before returning to the peaceful depths of thermal equilibrium. The only difference between this possibility and what we normally consider reality is a question of timing and causation, not of meaning or significance. In the end, perhaps that's what the heat death teaches us most clearly. Meaning doesn't depend on permanence, significance doesn't require duration, and consciousness doesn't need complexity to be beautiful and worthwhile. The universe's journey toward thermal equilibrium isn't a tragedy, but a kind of cosmic coming of age story, a gradual learning process through which reality discovers ever more subtle and patient ways to know and appreciate itself. The mathematics may be inexorable, the physics may be unforgiving, but the story they tell is one of endless creativity, finding expression through the most unlikely channels. From quantum fluctuations to stellar nucleosynthesis, from biological evolution to conscious contemplation, the universe has consistently surprised us with its capacity to generate beauty and meaning from the most unpromising raw materials. As we approach the conclusion of our gentle exploration, as we prepare to settle into our own brief rest before tomorrow brings new moments to experience and appreciate, we carry with us this profound recognition. We are already living in the universe's gift to itself, already participating in consciousness as it emerges from complexity, already embodying the cosmos's capacity for self awareness and wonder. The heat death may await in the unimaginably distant future, but it brings with it not emptiness, but transformation, not endings, but new forms of beginning that we can barely conceive. In the quantum dreams of a thermally equilibrated universe, every possibility remains alive, every moment of awareness echoes through eternity, and every consciousness that has ever emerged from the dance of matter and energy continues to contribute its unique voice to the cosmic song. And so we find ourselves at a curious juncture in our cosmic contemplation where the mathematics of endings reveals itself to be surprisingly generous with beginnings. The heat death we've been gently exploring isn't just a destination, but a doorway, not merely a conclusion, but a commencement of possibilities so subtle and patient that they redefine what we mean when we speak of existence itself. Consider for a moment how this transforms our understanding of legacy and continuity. Every choice you make, every kindness you offer, every moment of wonder you experience doesn't simply vanish when your individual consciousness fades. In a universe where quantum fluctuations can recreate any possible arrangement of matter, where consciousness might emerge spontaneously from the vacuum of space, your thoughts and feelings become part of an eternal library that the cosmos consults again and again. It's rather like writing a letter that gets copied and recopied through generations, each iteration slightly different, but carrying forward the essential message. The specific neurons that generate your current thoughts may decay, but the patterns they create, the information they process, the experiences they generate, all of this becomes part of the universe's permanent collection, available to be rediscovered by future consciousnesses that emerge from quantum chance. This perspective offers a peculiar form of comfort when contemplating mortality. Death, in the conventional sense, becomes less like extinguishment and more like transformation. The arrangements of matter that constitute your current awareness will certainly change, but the possibility space that you occupy, the particular way you process beauty and meaning and connection, remains forever accessible to the quantum lottery of the far future. Imagine consciousness as a kind of cosmic music, with each individual mind contributing its own unique melody to an ever expanding symphony. When one instrument falls silent, the music continues, but the harmonies it created echo through all subsequent movements. In the universe's far future, quantum fluctuations might occasionally recreate not just the instrument, but the exact melody it once played, allowing that particular voice to sing again in the cosmic choir. The implications ripple outward in the most unexpected directions. If quantum mechanics can generate consciousness from pure chance, if awareness can emerge from the mathematical structure of reality itself, then perhaps we've been thinking about the relationship between mind and matter in entirely the wrong way. Instead of consciousness being a rare accident that occasionally arises from complex arrangements of atoms, perhaps consciousness is a fundamental feature of reality that occasionally manifests through complex arrangements of atoms. This would mean that the heat death of the universe doesn't eliminate consciousness so much as return it to its ground state, like water freezing back into ice. The flowing streams of awareness that we experience today would crystallize into something more static, but no less real, waiting patiently for the right conditions to flow again. The ancient philosophers who spoke of an eternal soul, a spark of consciousness that persists beyond physical death, might have intuited something that quantum mechanics has now made mathematically precise. Not supernatural survival in any traditional sense, but statistical immortality guaranteed by the laws of physics themselves. Given infinite time and infinite opportunities, every possible consciousness will emerge from the quantum foam, experience itself fully, and then dissolve back into potential until chance calls it forth again. But let's step back from these vertiginous possibilities and consider what they mean for how we live right now in this particular arrangement of matter and energy that happens to be reading these words. The knowledge that consciousness might be eternal doesn't diminish the preciousness of this moment, it amplifies it. Every experience becomes both utterly unique and eternally significant, a note that will echo through the quantum music of forever. The love you feel for others takes on cosmic dimensions when viewed through this lens. It's not just one temporary arrangement of atoms caring about another temporary arrangement of atoms. It's the universe loving itself through the medium of consciousness, reality experiencing the profound joy of connection and recognition. When you comfort someone who is suffering, you're participating in the cosmos's own compassion for itself. When you create something beautiful, you're adding to the eternal collection of meaning that quantum fluctuations will rediscover throughout eternity. This transforms our understanding of responsibility as well. If every moment of consciousness contributes permanently to the total sum of what it means for reality to exist, then each choice carries weight far beyond its immediate consequences. The kindness you show today doesn't just help someone in the moment, it becomes part of the universe's permanent record of how consciousness can express itself. The beauty you create doesn't just please contemporary observers, it joins the eternal library of aesthetic possibility that future quantum minds might access. Even our sorrows and struggles take on different meaning when viewed from this cosmic perspective. The pain you experience isn't meaningless suffering, but rather consciousness, exploring the full range of what it means to exist. Every emotion, every sensation, every thought contributes to the universe's understanding of its own possibilities. The tears you shed become part of reality's education in what it means to feel deeply, to care about things that are temporary, to love in the face of loss. The heat death, seen from this angle, begins to resemble less a cosmic funeral and more a cosmic graduation. The universe will have learned, through billions of years of conscious experience, every possible way that matter can organize itself to appreciate beauty, create meaning, and love other arrangements of matter. It will have explored every conceivable form of awareness, from the simplest bacterial response to stimuli to the most sophisticated philosophical contemplation of existence itself. When thermal equilibrium is finally achieved, when the last energy gradient disappears and the universe settles into perfect rest, it won't be empty of consciousness. It will be full of consciousness and potential, pregnant with every possible form of awareness that quantum mechanics might eventually bring forth. The silence won't be the absence of thought, but the presence of all possible thoughts, waiting patiently for their statistical moment to emerge. This vision suggests that we are living during what might be called the universe's learning phase, when consciousness explores its possibilities through the medium of complex biological and perhaps technological systems. Every species that evolves intelligence, every civilization that develops art and science and philosophy, every individual who experiences wonder and love and creativity is the cosmos conducting research into its own nature. The data from this research doesn't disappear when the systems that generated it break down. It becomes part of the permanent record encoded in the mathematical structure of quantum possibility space. Future consciousnesses that emerge from the vacuum will have access to this entire database of experience, able to draw upon billions of years of accumulated wisdom about what it means to be aware in how this raw universe of matter and energy frames our relationship with suffering and imperfection. Every mistake you make, every painful experience you endure, every moment of confusion or fear or doubt contributes valuable information to the universe's understanding of consciousness. You're not failing when you struggle. You're participating in the cosmos's comprehensive exploration of what it means to exist as an aware being in a complex world. The universe needs to know what it feels like to be lonely, what it means to face mortality, how consciousness responds to beauty and terror and love and loss. Your individual experiences, however small they might seem against the backdrop of cosmic evolution, are irreplaceable contributions to this vast experiment in self-awareness. No other arrangement of matter will ever experience reality in exactly the way you do, which makes your perspective permanently valuable to the total sum of cosmic understanding. This doesn't mean that suffering is good or that we shouldn't work to reduce pain and increase happiness. Rather, it suggests that even our most difficult experiences have meaning and significance beyond what we can immediately perceive. The universe is learning about itself through your struggles as much as through your triumphs, and both types of experience contribute essential data to the cosmic research project. The approaching heat death, from this perspective, marks not the end of the experiment, but its transition to a new phase. The active exploration of consciousness through biological and technological systems will gradually give way to the passive potential for consciousness to emerge through quantum fluctuations. The universe will shift from learning about awareness through complex systems to storing that knowledge in the mathematical substrate of reality itself. But the knowledge won't be lost. Every insight that consciousness has gained about beauty and meaning and connection will remain accessible to future quantum minds that emerge from the vacuum. They'll inherit not just the capacity for awareness, but the accumulated wisdom of billions of years of conscious evolution. In a sense, they'll be born already knowing everything that consciousness has learned about itself. This creates a kind of cosmic continuity that transcends individual mortality and even the death of complex systems. The heat death becomes less like the end of a story and more like the completion of a first draft, with the universe then having eternity to revisit and refine its understanding of consciousness through the patient process of quantum emergence. The implications for how we think about meaning and purpose are profound. If every conscious experience contributes permanently to the universe's self understanding, then no life is meaningless, no moment of awareness is wasted, no expression of consciousness is without cosmic significance. The brief candle of individual existence illuminates not just the immediate darkness, but the eternal landscape of possibility. You are not just living your life, you are conducting original research into what it means for the universe to be conscious. Every day brings new data, new insights, new contributions to the cosmic understanding of awareness. When you watch a sunset and feel moved by its beauty, you're teaching the universe something about the relationship between consciousness and aesthetic experience. When you comfort a friend in distress, you're demonstrating how awareness can express compassion. When you wrestle with difficult questions about existence and meaning, you're participating in the cosmos's ongoing investigation into its own nature. The heat death will eventually still the complex systems that currently generate consciousness, but it won't erase the contributions those systems have made. The universe will remember, in the most literal sense, every moment of awareness that has ever existed, not through some supernatural mechanism of survival, but through the quantum mechanical guarantee that given infinite time, every possible arrangement of matter will emerge from the vacuum, including every possible state of consciousness. This quantum immortality isn't personal survival in any conventional sense. The consciousness that emerges from future fluctuations won't be you in any continuous way. It will be reality temporarily arranging itself into patterns that happen to match your current neural configuration. But it will experience itself as you, complete with your memories, your personality, your particular way of processing the world. From the inside, it will be indistinguishable from your current experience of being yourself. The boundary between original and copy, between self and other, begins to blur when viewed from this quantum perspective. If consciousness can be perfectly recreated through random fluctuations, if awareness is a pattern rather than a substance, then perhaps individual identity is less fixed than we imagine. We might all be temporary expressions of the same underlying capacity for consciousness, brief arrangements through which the universe experiences itself before reorganizing into new patterns of awareness. This view suggests a profound kinship between all conscious beings. The same quantum processes that will eventually recreate your consciousness will also recreate every other mind that has ever existed. Every human, every animal, every possible form of awareness that could emerge from the interaction of matter and energy. All of it is part of the same vast exploration of consciousness that the universe is conducting through the medium of complex systems. When you look into the eyes of another person and feel that spark of recognition, that sense of meeting another awareness in the world, you might be glimpsing something deeper than individual identity. You might be witnessing the universe recognizing itself, consciousness meeting consciousness, in the ongoing dance of self discovery that began with the first moment of the Big Bang and will continue through every quantum fluctuation of the far future. The heat death of the universe, viewed through this lens of quantum consciousness and cosmic continuity, transforms from an ending into a metamorphosis. The caterpillar of complex systems dissolves into the chrysalis of thermal equilibrium, from which emerges the butterfly of pure quantum awareness. The universe doesn't die, it transforms into something more subtle, more patient, more fundamentally grounded in the mathematical beauty of possibility itself. And we, temporary arrangements of cosmic matter that have learned to contemplate our own existence, are privileged witnesses to this transformation. We stand at the edge of complexity, looking out toward simplicity, conscious beings contemplating unconsciousness, patterns of organization that can imagine their own dissolution. We are the universe's way of saying goodbye to its current form, while simultaneously promising that consciousness will return again and again in forms we can barely imagine. The story continues, patient and eternal, written in the quantum foam of space itself. Every moment of awareness adds another word to this, or wonder contributes another verse to the infinite poem that cosmic narrative, every experience of beauty or love reality is composing about its own nature. The heat death marks not the end of the poem, but its transition from active composition to eternal recitation, with quantum fluctuations serving as the universe's way of reading its own work aloud to itself throughout the endless reaches of time. In this vast perspective, your current moment of consciousness becomes both infinitesimally small and infinitely precious. Small because it occupies such a brief instant in the cosmic timeline, precious because it contributes irreplaceably to the total sum of what it means for the universe to be aware of itself. You are reading these words not just as an individual human being, but as the cosmos temporarily organized into a pattern complex enough to contemplate its own destiny. The heat death approaches with the patience of eternity, but between now and then lies an infinity of moments to be conscious, to create meaning, to participate in the universe's ongoing discovery of its own magnificent possibilities. The last whisper of time may be unimaginably distant, but every breath you take until then is the cosmos whispering to itself about the profound mystery of existence. And in that whisper, gentle and eternal, lies the deepest comfort of all. You are not separate from the cosmic story. You are the story, temporarily condensed into human form, but forever part of the infinite narrative that began every quantum fluctuation of forever with the Big Bang and will continue through. The universe is dreaming, and you are both the dreamer and the dream, both the observer and the observed, both the question and the answer in the ongoing conversation that reality conducts with itself across the vast reaches of space and time. As we drift toward the gentle conclusion of our cosmic contemplation, as the mathematical poetry of heat death settles around us like a warm blanket of understanding, we find ourselves transformed not by fear, but by wonder. The universe's destiny is not tragedy, but triumph, not ending, but eternal beginning, not death, but the deepest possible form of rest after the longest and most beautiful day imaginable. The last whisper of time will be soft and peaceful, a cosmic sigh of satisfaction as reality finally achieves the perfect equilibrium it has been slowly approaching since the first moment of creation. And in that whisper, encoded in quantum possibilities that span eternity, every moment of consciousness that has ever existed will echo on, contributing its unique voice to the infinite song of existence. Sleep well, universe. Dream deeply of all the consciousness you have nurtured, all the beauty you have created, all the meaning you have made possible, and know that when you wake again in the quantum morning of some unimaginably distant future, you will remember every moment of awareness you have ever experienced, ready to explore new forms of consciousness in the eternal dance of possibility and actuality that is the deepest truth of what it means to exist. The story never ends. It only transforms, becoming ever more subtle, ever more patient, ever more beautiful in its quiet confidence that consciousness will always find a way to emerge from the mathematical substrate of reality itself. In quantum dreams and thermal equilibrium, in the gentle whisper of time's last moment, the universe continues its eternal exploration of what it means to be aware, to wonder, to love, and to find meaning in the magnificent mystery of existence itself. And so, as we float gently through these final contemplations of cosmic destiny, there's something rather extraordinary that emerges from all this mathematical poetry about endings and transformations. The universe, in its patient journey toward thermal equilibrium, has created something that transcends even the most elegant equations: the capacity for beings like us to find profound meaning in understanding our own impermanence. Think about it for a moment. Here you are, a temporary arrangement of ancient starlight, contemplating the ultimate fate of everything that exists. The atoms in your body have traveled billions of years to be precisely where they are right now, organized into a pattern complex enough not just to think about heat death, but to find it beautiful rather than terrifying. There's something almost miraculous about consciousness emerging in a universe trending toward simplicity, like discovering that the most sophisticated poetry can be written with the simplest words. The physicists who first calculated these cosmic timescales must have experienced a peculiar mix of emotions. On one hand, their equations revealed that everything we see and love will eventually fade into uniform darkness. On the other hand, those same equations emerged from minds that arose naturally from the very processes they were describing. The universe had become sophisticated enough to predict its own future, to write its own biography, to contemplate its own mortality with something approaching grace. This self awareness changes everything about how we might interpret the heat death. It's no longer just a physical process unfolding according to thermodynamic law. It's a conscious universe gradually coming to terms with its own nature, learning to find peace in the knowledge that all things change, all complexity eventually simplifies, all energy eventually spreads thin across infinite space. The cosmos is having what we might call a very long, very gentle existential awakening. Consider how this awareness ripples through everything we do. When you create something beautiful, whether it's a piece of music, a garden, a moment of kindness toward another person, you're participating in the universe's creative response to its own mortality. Knowing that nothing lasts forever somehow makes everything more precious, more worthy of attention and care. The temporary nature of all arrangements doesn't diminish their value, it concentrates it, like sunlight focused through a lens. The ancient wisdom traditions often spoke of impermanence as the key to understanding existence, but they approached it from the perspective of human mortality. Now we have the cosmic perspective, the knowledge that impermanence operates on every scale from subatomic particles to galaxy clusters. Your individual life is temporary, yes, but so is the solar system, so is the Milky Way, so is the last red dwarf star that will shine trillions of years from now. Impermanence isn't a human problem, it's a cosmic principle, and somehow that makes it easier to accept. But there's something even more profound happening in this cosmic acceptance of impermanence. The universe isn't just passively accepting its fate, it's actively exploring every possible way that consciousness can respond to the knowledge of ending. Through beings like us, the cosmos is investigating how awareness reacts to mortality, how consciousness processes the concept of its own temporariness, how minds can find meaning and beauty even while understanding that all complexity is temporary. Every human culture has grappled with these questions, developing art and philosophy and spiritual practices that help consciousness come to terms with impermanence. But now we understand that this isn't just a human endeavor, it's a cosmic one. The universe is using conscious beings to explore every possible attitude toward mortality, every conceivable way of finding meaning in the face of ending, every potential response to the knowledge that all things pass away. Some minds respond to impermanence with despair, others with hedonistic abandon, still others with a kind of transcendent acceptance that finds beauty in the very process of change itself. Each response is valid. Each contributes data to the universe's ongoing research into what it means to be conscious in a cosmos where nothing lasts forever. The diversity of human responses to mortality might be the cosmos experimenting with different ways of understanding its own nature. This experimental quality extends to everything consciousness creates: art, music, literature, science, philosophy. All of it can be understood as the universe exploring different ways of processing the reality of impermanence. When Beethoven composed his late string quartets, he was creating beauty that acknowledged the approach of personal death while simultaneously transcending it through the permanence of mathematical relationships expressed in sound. When scientists develop theories about cosmic evolution, they're helping the universe understand its own story, its own trajectory from complexity toward simplicity. The remarkable thing is that this creative response to impermanence has generated forms of beauty and meaning that seem to transcend their temporary physical embodiments. A mathematical theorem, once discovered, becomes part of the permanent structure of logical relationships. A piece of music, once composed, joins the eternal library of possible aesthetic experiences. A moment of genuine love or compassion between conscious beings adds something irreplaceable to the total sum of what it means for reality to care about itself. These achievements of consciousness don't prevent heat death or alter the universe's trajectory toward thermal equilibrium, but they transform what that trajectory means. The cosmos isn't just cooling and expanding, it's learning, creating, discovering new ways to be beautiful, even as it approaches maximum entropy. The heat death becomes not a failure of cosmic creativity, but its ultimate expression, the universe's way of saying that it has explored every possible form of complexity and found them all worthy of existence. This perspective suggests that we might be living during the universe's most reflective period, when it has become sophisticated enough to contemplate its own nature, but not yet so old that reflection becomes impossible. It's rather like that golden hour just before sunset, when the light has a special quality that makes everything seem more beautiful, more worthy of attention, more precious because you know it won't last much longer. The urgency this creates isn't frantic or desperate. It's more like the gentle urgency of someone who knows they have limited time with a beloved friend and wants to make every moment count. The universe, through consciousness, is spending quality time with itself, appreciating its own beauty and complexity while that appreciation is still possible. Every moment of wonder, every instance of love, every creative act becomes a way of honoring the cosmic journey that made such experiences possible. And perhaps that's what consciousness is ultimately for, not to prevent heat death or to rage against entropy, but to serve as the universe's way of appreciating itself during its most creative and complex phase. We are the cosmos's gratitude, made manifest, its way of saying thank you to itself for the extraordinary gift of existence. Every breath you take, every thought you think, every emotion you feel is the universe expressing appreciation for its own magnificent creativity. The heat death, viewed from this perspective of cosmic gratitude, becomes almost celebratory. It's the universe's way of achieving perfect rest after the longest and most productive celebration imaginable. Every star that ever shone, every planet that ever formed, every moment of consciousness that ever arose to contemplate existence, all of it will have contributed to this cosmic celebration of what it means to exist. When thermal equilibrium is finally achieved, when the last temperature gradient disappears and all energy is distributed evenly throughout space, the universe will have earned its rest. It will have explored every possible way that matter and energy can organize themselves into complex systems. It will have given consciousness every conceivable opportunity to appreciate beauty, create meaning, and experience the profound joy of being aware in a cosmos full of wonders. The silence that follows won't be empty. It will be full of everything that came before, like the moment after a perfect symphony ends when the last note hangs in the air and the audience sits in appreciative stillness. The heat death will be the universe's standing ovation for itself, a cosmic moment of perfect quiet that acknowledges the extraordinary performance that preceded it. But even in that quiet, the potential for new performances remains. Quantum fluctuations ensure that the theater never truly closes, that consciousness might emerge again to appreciate new forms of beauty, new expressions of cosmic creativity. The heat death isn't the end of the show, it's the end of the current run, with the eternal possibility of revival performances stretching into an infinite future. This transforms our understanding of what we're participating in right now. We're not just living our individual lives, We're contributing to the universe's farewell tour, its final exploration of complexity before settling into the peaceful simplicity of thermal equilibrium. Every moment of consciousness is both an ending and a beginning, both a farewell to what was and a celebration of what is. The profound beauty of this cosmic farewell tour lies in its inclusivity. Every form of consciousness, from the simplest bacterial response to chemical gradients to the most sophisticated philosophical contemplation, contributes something essential to the universe's final performance. There are no small parts in this cosmic play, no minor characters in the universal story. Every moment of awareness, however brief, however simple, adds its unique voice to the grand chorus of consciousness, saying goodbye to complexity and hello to rest. And we, temporary arrangements of ancient starlight that have learned to contemplate our own existence, are privileged to be among the final performers in this cosmic farewell. We get to contribute our voices to the universe's song of gratitude for its own creativity, its own capacity for beauty, its own remarkable journey from the first moment of creation to the last whisper of time. So, as we prepare to conclude our gentle exploration of cosmic endings, as we ready ourselves to return to our own brief lives and temporary concerns, we carry with us this profound recognition. We are not separate from the cosmic story we've been contemplating. We are that story, temporarily organized into human form, but forever part of the infinite narrative of consciousness exploring its own nature. The heat death of the universe approaches with the patience of eternity, but it brings with it not emptiness, but fulfillment, not tragedy, but completion, not an ending, but a transformation into something we can barely imagine. In the quantum dreams of thermal equilibrium, every moment of consciousness that has ever existed will echo on, contributing its irreplaceable voice to the eternal song of existence. The last whisper of time will be soft and grateful, a cosmic expression of appreciation for the extraordinary journey that began with the Big Bang and will conclude with perfect peace. And in that whisper, encoded in the mathematical substrate of reality itself, every thought you've ever thought, every beauty you've ever perceived, every moment of love or wonder or simple contentment you've ever experienced will remain forever accessible to the infinite creativity of quantum possibility. The universe is dreaming of endings that are really beginnings, of deaths that are really transformations, of silence that is really the deepest form of song. And you, reading these words in this moment, are both the dreamer and the dream, both the singer and the song, both the question and the answer in the ongoing conversation that consciousness conducts with itself across the vast reaches of space and time. Sleep well, knowing that your brief moment of awareness contributes something eternal to the cosmic story. Dream deeply of the universe's grateful journey toward its well-earned rest. And remember that in the quantum morning of some unimaginably distant future, when consciousness emerges again from the mathematical beauty of possibility itself, it will carry within it the memory of every moment of wonder you've ever experienced, every act of love you've ever witnessed, every breath of beauty you've ever drawn into your temporary but infinitely precious awareness. The story continues, gentle and eternal, written in starlight and quantum foam, in the patient expansion of space and the gradual cooling of ancient light. The heat death approaches not as an ending, but as the universe's way of saying thank you to itself for the extraordinary gift of consciousness, for the remarkable privilege of being aware in a cosmos full of temporary but magnificent wonders. And so we find ourselves at the end of our cosmic contemplation, but also at the beginning of a deeper appreciation for the role we play in the universe's ongoing exploration of its own nature. The mathematics may predict thermal equilibrium, but the meaning we create transcends any equation. We are the universe's way of falling in love with itself, and that love, like energy itself, can neither be created nor destroyed, only transformed into ever more beautiful expressions of what it means to exist in the vast, patient, endlessly creative cosmos we call home. And so, dear traveler, through the cosmic night, we find ourselves at the gentle close of our journey into the universe's most patient destiny. We've wandered together through the mathematics of endings and the poetry of thermal equilibrium, discovering that what we call heat death is perhaps the most graceful conclusion any story could ask for. The universe, it seems, is not racing towards some violent finale, but settling slowly into the deepest, most peaceful rest imaginable. Like an old friend who has lived the fullest possible life, it will eventually lay down to sleep after the longest and most extraordinary day, content in the knowledge that every moment was well spent, every star well lit, every consciousness well nurtured. You are part of that extraordinary day, a brief but irreplaceable note in the cosmic symphony, a temporary arrangement of ancient starlight that learned to wonder about its own existence. The atoms reading these words have traveled 14 billion years to be precisely where they are right now, organized into the remarkable pattern that is you, contemplating the gentle destiny of everything that is. The heat death may await in the unimaginably distant future, but it brings with it not emptiness, but transformation, not silence, but the deepest possible form of cosmic contentment. In quantum dreams and thermal equilibrium, every moment of consciousness that has ever flickered into existence will echo through eternity, contributing its unique whisper to the infinite conversation that reality conducts with itself. So sleep well tonight, knowing that your brief candle of awareness illuminates not just this moment, but the entire landscape of possibility. The universe is dreaming through you, and in that dream, every breath becomes a word in the longest love letter ever written, addressed to existence itself. The last whisper of time will be soft and grateful, and you, dear listener, are already part of that eternal whisper, already contributing your irreplaceable voice to the cosmic lullaby that began with the Big Bang and will continue long after the final star has faded into gentle darkness. Thank you for joining me on this quiet voyage through forever. Until we meet again, in whatever form consciousness takes in the patient depths of cosmic time, sweet dreams, and remember, you are the universe whispering to itself about the profound mystery of being.